I'll discuss one very good question, which will cover most of the basic ideas clearly. Okay, we do have the temperatures of this 873 Kelvin. This we don't know. Call this is T2, temperature of, okay, this is 300 Kelvin. So this is the heat engine. This is a refrigerator. Q4. This is Q3. 360 joules lost to overcome friction. Okay, we do have a system. Okay, here Q1, here it will extract from the hot body 200 joules and it will give out Q2 like this. And this is a refrigerator. This is a cold body and definitely this is a hot body. This one. So now what is the Q4 is what is asking, Q3, Q4, all this one. So what is this? The heat engine does work. The work done by the heat engine, what will happen? A part of work what happen will be lost as heat to overcome friction, and the remaining what happen, the work will become the work input for a refrigerator. And the refrigerator, what it does, by doing work, it will extract it from the cold body and give it to the hot body. So what is the question that I'm asking is like, find this Q4, find the heat rejected, find the heat rejected by the refrigerator to the this 313 Kelvin, this one. I'll just write Q4, find Q4. I can make a combination like this, heat engine and refrigerator. Okay, we'll do one thing for heat engine. What is the formula? Yes, anybody? Formula? Temperature of hot minus temperature of cold by, or 1 minus temperature of the hot body, or say temperature of cold body, 313 by 873. Will I agree? Or I'll write this one, temperature of cold body okay, this is, so what is the temperature for heat engine? That this will become hot body. This will be for like a cold body, or just I'll write or say like a, this is some bath. Temperature of bath. Oh, this is sorry. Temperature of bath, and there's a temperature of hot body. The cold body is what will become bath here. So 313 by 873. Anybody value of this? Okay, no, this is, so this is heat engine. Any other formula for heat engine? Mechanical work done by the heat engine by heat extracted from the hot body. That is Q1. No? Let me equate these two. WHE by Q1 equal to, we know Q1 2000. Anybody value WHE? What is this mechanical work done?
1283.
How much?
1283.
12?
83.
86, huh? Yeah. Mechanical work done by heat engine. Okay, in this mechanical work done, a part T60 joules is lost as lost to overcome friction. Then how much will be available for refrigerator? The difference of this. So shall we write one more equation here? WHE is equal to 360 plus this one. So 1286 equal to 360 WRE. Value of WRE. Anybody? Value of WRE?
920.
9?
920.
920, yeah? How 920? 86 is there?
926.
926.
926. Yeah. Okay, there's a WRE. Okay, now for refrigerator, what we can write the formula? So I think just formula based on, because already now we know concept. Okay, for refrigerator, I'll proceed like this. Coefficient of performance of refrigerator, RE, I think beta RE, I'll write it in short. Yeah. Temperature of hot body. Shall I think already, let me write the values. Temperature of cold body. This is temperature of bath. Okay, this is the thing. So this is coefficient of performance of this should be equal to 253 by 313 minus 253. Okay, there's a one value. And other thing, what is one more thing is equal to heat extracted from the cold body by mechanical work done. So we know beta RE, we know WRE. We'll get Q3. If you know WRE Q3, we'll get Q4. Then Q2 plus Q4, what I can find? Also find heat Shall I make question like this? Find the total heat absorbed by the bath. Bath will absorb Q2 plus Q4. Okay, first I got beta RE. Okay, no. How to get Q2 and Q4? Q2 is what is available from here, no, in the heat engine, and Q4 is available from here. Anybody Q3? Value of Q3? WRE we know 926.
3092.
30?
390.
390. Yeah. Okay, now we know Q3. Okay, let's
Sir,
calculate
3904.
3904. Okay, usually beta, how much you're getting? Anybody beta RE?
4.2.
4 point. Okay, the beta will be around 2 to 6. In between 2 and 6, it will be adjusted. They may ask you these questions also. You have to be careful. Okay, we got Q2. No, I want Q2 plus Q4. Okay, how to bring Q2? Any equation can we write here? Q1 is equal to Q2 plus WH. We know Q1, we know WH, will get Q2. So what is Q2 is equal to? This value Q2. I will adjust all in one page because some of you will take printout. No, it'll be. Yeah. Okay. The next part of the discussion is anybody value Q2 1283. Okay, fine. Yeah, 1283 joules. Okay, this is Q2. How to bring Q4? So for Q4 again WRE. This is for what we wrote for heat engine. For refrigerator. For refrigerator, WRE plus Q3 should be equal to Q4. WRE is what we have calculated 926. Q3 already we know 394, so we'll get Q4. Anybody value Q4? WHE 1283. Sir, what is WHE? Work done, mechanical work done by heat engine. Look at here, Q1 is equal to heat extracted, so heat supplied by the source is equal to mechanical work done by heat engine plus heat rejected. This is what I'm so we are discussing again heat engine. I'm writing separately. You have to look at this part. This is for heat engine. Again, this is for refrigerator. Okay, or okay, this one, yeah. You are getting confusion with this. I'll do one thing. Okay, ma, I think no, there should not be any confusion. Anybody value Q4? Q4 value, tell the Q4 value. Hurry up, Q4 value. Q2, why different answers?
Sir, Q2 is 714.
714, huh?
Sir, Q4 is 4830, sir.
Yes.
4830.
30.
Okay, check the values. Huh? 4830. Okay, fine. Huh? Q2 717. Yeah. Okay, now what is the question that is asked? Find the heat absorbed by the bath, or find the total heat absorbed by the bath. So how much of heat is entering the bath? Q2 and Q4. Not 360 joules is heat lost to overcome friction. So what is the total heat that is entering the bath? Q2 plus Q4. So what would be your answer? Heat. Anybody value? I think this will be 5,000. 5,500.
Sir, 5544.
5544. Huh?
Yes.
Okay, like this, some heat engine, refrigerator, heat engine and heat pump, refrigerator, heat pump can be mixed up here. You should work out. Shall I give one problem on this? Another one. Can you work out? Similar to this one. Huh? I'll give one problem so you can practice this.